Good morning, students. Today's part is limiting reagent and excess reagent. This is quite difficult part of this lesson. Let us start with the definition of limiting reagent. What is the definition of limiting reagent? The reactant which gets consumed and limits the amount of product formed. It's called limiting reagent. The reactant which gets consumed and limits the amount of product formed is called limiting reagent. So, for example, consider the formation of nitrogen dioxide from nitric oxide and oxygen. Consider the formation of nitrogen dioxide, that is NO2, from nitric oxide NO and oxygen O2. Okay. Suppose initially we take 8 moles of nitric oxide and 7 moles of oxygen. Suppose initially we take 8 moles of NO and 7 moles of O2. To determine the limiting reagent, calculate the number of moles of NO2 produced from the given initial quantity of NO and O2. Once again, to determine the limiting reagent, calculate the number of moles of nitrogen dioxide, that is NO2, produced from given initial quantity of NO and O2. The initial quantity of NO and O2 are given 8 moles of NO and 7 moles of O2. Okay, therefore, for 8 moles of NO, the number of moles of NO2 produced is 8 moles of NO into, in the reaction, how many moles of NO2 and NO given? 2 moles of NO2 and 2 moles of NO is given for the reaction. So, therefore, for 8 moles of NO, the number of moles of NO2 produced is 8 moles of NO into ratio of 2 moles of NO2 divided by 2 moles of NO. So, this calculation will get 2 will get cancelled. So, it remains 8 moles of NO2. So, therefore, 8 moles of NO produces how many moles of NO2? 8 moles of NO2. Now, for 7 moles of O2, the number of moles of NO2 produced is, for 7 moles of O2 oxygen, the number of moles of NO2 produced is 7 moles of O2 into 2 moles of NO2 and 1 mole of O2. Oxygen given in the reaction, that is 1 mole. So, that's why 2 moles of NO2 divided by 1 mole of O2. So, 7 2s are 14 divided by 1, that is 14. So, 14 moles of NO2 produced by using 7 moles of O2. Okay. So, this is the number of moles. So, which produces lesser number of moles of NO2? Which produces lesser number of moles of NO2? NO produces lesser number of moles of NO2, that is 8 moles. So, that's why NO is a limiting reagent, and oxygen produces larger moles of NO2, and because of that, oxygen is a excess reagent. Since 8 moles of NO produces smaller amount of NO2, since 8 moles of NO produces smaller amount of NO2 and 7 moles of O2 produces larger amount of NO2, the reagent which produces lesser amount of product, is called limiting reagent, and the reagent which produces larger amount of product is called excess reagent. Hence, in this reaction, which is a limiting reagent, hence NO is limiting reagent and O2 is excess reagent, because of NO produces lesser amount of NO2 and O2 produces larger amount of NO2. So, that's why NO is a limiting reagent and O2 is a excess reagent. Okay, this is a explanation, but numericals are different. Okay, first example problem, urea, that is NH2 twice CO, it is known as urea. Urea is prepared by reacting ammonia with carbon dioxide. Urea is prepared by reacting ammonia with carbon dioxide. So the reaction is given 2NH3 gas, NH3 means ammonia, 2NH3 gas plus CO2 gas, CO2 means carbon dioxide, gives urea NH2 twice CO, NH2 twice CO aqueous plus water. Okay. So in one process, you are given the masses of ammonia and carbon dioxide. In one process, 637.2 gram of ammonia. In one process, 637.2 gram of ammonia are treated with 1142 gram of carbon dioxide, that is CO2. Once again, in one process, 637.2 gram of ammonia are treated with 1142 gram of carbon dioxide. So, out of two reactant, which is limiting reagent, you have to calculate. Out of these two reactant, that is ammonia and carbon dioxide, which is the limiting reagent, calculate the mass of urea form. Urea is an product. Calculate the mass of urea form, and at the end of reaction, how much excess reagent left unreacted. How much excess reagent left unreacted. Okay. So these are the three calculations. You have to calculate these three factors. Okay. Now here, first of all, determine who is the excess reagent and who is the limiting reagent. Now, first of all, write down the reaction. The given reaction is ammonia 2 moles of NH3 plus CO2 gives urea plus water. Okay. So calculate the molar mass of ammonia. 1 mole of ammonia is equal to 17 gram. 1 mole of ammonia is equal to nitrogen, it containing 1 nitrogen and 3 hydrogen. 1 nitrogen, that is 14, plus 3 hydrogen, it is 3. So 14 plus 3 17. 1 mole of ammonia is equal to 17. So therefore 2 moles of NH3 is equal to 34. 1 mole of CO2, it containing 1 carbon and 2 oxygen. 12 plus 32. 12 plus 32, that is 44. Urea containing 2 nitrogen, 4 hydrogen, 1 carbon and 1 oxygen. And by adding atomic masses of nitrogen, hydrogen, carbon and oxygen, the molar mass of urea gives, that is 60 gram, and water, 1 mole of water is equal to 18 gram. Now you are given, in this reaction you are given the masses of ammonia and carbon dioxide, that is 637.2 gram of ammonia reacts with 1142 gram of carbon dioxide to produce how many grams of urea? You have to determine the mass of urea form, and which is the limiting reagent and which is the excess reagent, and how many mass of excess reagent left unreacted. These are the problem. Okay. Now, for 637.2 gram of ammonia, the moles of urea produced is, calculate the number of moles of urea using masses of ammonia and carbon dioxide, using masses and molar masses of ammonia and carbon dioxide. First of all, 637.2 gram of ammonia, for 637.2 gram of ammonia, the moles of urea produced is, okay. So therefore, moles of urea is equal to mass of ammonia divided by molar mass of ammonia. NH3 means ammonia. Using mass and molar mass of ammonia, calculate the moles of urea. So mass of ammonia divided by molar mass of ammonia. Mass of ammonia is 637.2 divided by molar mass is 34. Taking log, so therefore anti-log, 2 point characteristic is 2, and log of 63 in 7 and 2 is 8042. Characteristic is 34 की characteristic 1 है, minus 1 point. Log of 34 in 0 is 5315. Okay, by subtracting these two factors we get 1.2727, and log anti-log of 2.27 into 7 is 1874 because of 1 is there, so that's why the characteristic is donated as after 2 numbers, so the final answer is 18.74 moles. Okay, so this is the number of moles of urea produced by using mass and molar mass of ammonia. Okay, now calculate the number of moles of urea produced by using mass and molar mass of carbon dioxide. So therefore, for 1142 gram of carbon dioxide, the moles of urea produced is, for 1142 gram of carbon dioxide, the moles of urea produced is, so moles of urea is equal to mass of carbon dioxide divided by molar mass of carbon dioxide. So mass of carbon dioxide is sorry 1142 divided by 44. Taking log, anti-log characteristic is 3 and log 0.577. Okay, minus 1 characteristic is 1 point, log of 44 in 0 is 6435, and subtraction of these two factors gives 1.4142, and by taking anti-log of 0.41 in 42 we get 2595, and by donating characteristic the final answer will be 25.95 mole. So which number of moles is lesser and which number of mole is larger? So 18.74 mole is lesser amount and 25.95 moles is a larger amount, larger moles. Okay, so therefore which is a limiting reagent? Ammonia produces lesser amount of urea and carbon dioxide produces larger amount of urea. So therefore, since 637.2 gram of ammonia produces smaller moles of urea, that is 18.74 mole, therefore ammonia is a limiting reagent. Similarly, 1142 gram of CO2 produces larger moles of urea, that is 25.95 mole, therefore carbon dioxide is a excess reagent. Okay, so excess reagent and limiting reagent. Now the mass of excess reagent CO2 reacted, excess reagent is carbon dioxide and the mass of carbon dioxide given is 1142. Okay, so now the mass of excess reagent CO2 reacted out of 1142, how many grams of carbon dioxide reacted? So mass of excess reagent reacted, फॉर्मूला इज बघा, फॉर्मूला आपको टेक्स्ट बुक में फॉर्मूला, ये प्रॉब्लम टोटली डिफरेंट है टेक्स्ट बुक में ये प्रॉब्लम टोटली डिफरेंट है, मैंने डिफरेंट मेथड से सॉल्व किया है. देखो, दिस इज द इजी मेथड to determine excess reagent and limiting reagent and to determine the mass of excess reagent reacted and mass of product form. So that's why ये formula जो है वो आप इस्तेमाल करो. So mass of excess reagent reacted is equal to mass of limiting reagent divided by molar mass of limiting reagent. Limiting reagent is ammonia ना. So mass of limiting reagent divided by molar mass of limiting reagent into आपको कार्बन डाइऑक्साइड का मास एक्सेस रिएजेंट रिएक्टेड निकालना है, इसलिए मोलार मास ऑफ कार्बन डाइऑक्साइड. वंस अगेन, मास ऑफ एक्सेस रिएजेंट रिएक्टेड इज इक्वल टू मास ऑफ लिमिटिंग रिएजेंट डिवाइडेड बाय मोलार मास ऑफ लिमिटिंग रिएजेंट इनटू मोलार मास ऑफ कार्बन डाइऑक्साइड. कार्बन डाइऑक्साइड इज अ excess reagent. Okay, so molar mass of carbon dioxide. So mass of limiting reagent is 637.2 divided by molar mass is 34 into molar mass of carbon dioxide is 44. So therefore by multiplying by dividing 34 for division 44 divided by 34, that gives 18.74 into 34 से ऊपर सॉरी log देख रहा हूँ, डायरेक्ट log. So that is 18 point, this ratio 637.2 divided by 34 is 18.74 here. This ratio gives 18.74. So that's why मैंने यहाँ पर डायरेक्ट लिख दिया है 18.74. दिस रेशियो, वैल्यू ऑफ दिस रेशियो इज 18.74 इंटू 44. सो देयरफॉर बाय टेकिंग लॉग 1.18 का लॉग 74 में 2727 into means plus 44 का log 1.6435. by adding these two factor we get 2.9162 and by taking antilog of 91 in 6-2. The antilog is 8245. Okay, and by donating characteristic, the final answer will be 824.5 gram. This is the mass of excess reagent reacted. Mass of excess reagent, that is CO2 reacted, is 824.5 gram. Okay, now mass of excess reagent CO2 unreacted. Unreacted means remains unreacted after completion the reaction. Okay, mass of excess reagent, that is CO2 unreacted, it is equal to 1000. Initial mass is given, that is 1142, and mass of excess reagent reacted is 824.5. So by subtracting these two factors, we get mass of carbon dioxide unreacted, that is 317.5 gram. This subtraction gives value 317.5. This is the mass of excess reagent unreacted. Reacted कितना आया है 824.5 and unreacted कितना आया है 317.5. Okay, now mass of urea formed. Mass of urea formed. Urea means NH2 twice CO. So mass of urea formed, the formula is mass of urea is equal to mass of limiting reagent. ऊपर का ही फॉर्मूला इस्तेमाल करना है. मास ऑफ लिमिटिंग रिएजेंट डिवाइडेड बाय मोलार मास ऑफ लिमिटिंग रिएजेंट इनटू, ऊपर क्या लिया था, मोलार मास ऑफ CO2, क्योंकि CO2 का मास निकालना था, यहाँ पर यूरिया का मास निकालना है, इसलिए मैं क्या करूँगा, मास ऑफ लिमिटिंग रिएजेंट डिवाइडेड बाय मोलार मास ऑफ लिमिटिंग रिएजेंट इनटू मोलार मास ऑफ यूरिया, क्योंकि यूरिया का मास निकालना है इसलिए यूरिया के मोलार मास से मल्टीप्लाई करना है. सो 637.2 डिवाइड बाय 34 इंटू 60, and this ratio is 18.74 into 60. मोलर मास ऑफ यूरिया इज 60 एंड 60 से मल्टीप्लाई कर दिया. सो एक जीरो डेसिमल पॉइंट बढ़ा दिया, 187.4 इंटू 6. सो 6 से मल्टीप्लाई करने के बाद मास ऑफ यूरिया फॉर्म इज 1124.4 ग्राम. 1124.4 gram of urea formed after the reaction between carbon dioxide and ammonia. Okay, so this is the first example. Second example, 6 gram of hydrogen reacts with 32 gram of oxygen. This is a simple example. 6 gram of hydrogen reacts with 32 gram of 6 gram of hydrogen reacts with 32 gram of oxygen to yield, to give water, which is limiting reactant. Which is limiting reactant. Find the mass of water produced and the amount of excess reagent left. Once again, क्या है प्रॉब्लम देखो, 6 gram of hydrogen reacts with 32 gram of oxygen to form water, which is the limiting reactant. Find the mass of water formed, produced, and the amount of excess reagent left. Okay, so first of all, the reaction is represented as reaction 2H2 gas plus O2 gas gives 2H2O liquid. Molar masses, hydrogen, 1 hydrogen is equal to 1, so therefore for 4 hydrogen it is 4 gram. 1 oxygen is equal to 16, so therefore for 2 oxygen 32, molar mass of oxygen is 32. 1 water molecule is equal to 18, so therefore 2 water molecule is equal to 36. Okay. Molar masses of hydrogen is 4 gram, oxygen is 32, water is 36. Okay. Now given mass, what is the mass of hydrogen given in this example? That is 6 gram. And mass of oxygen given, that is 32. Okay, same mass is given, 32 gram. Now, for 6 gram of hydrogen, the number of moles of water produced is 6 gram of hydrogen के लिए water कितने, water के number of moles कितने produce हो रहे देखते हैं. Moles of water is equal to mass of hydrogen divided by molar mass. Mass of hydrogen divided by molar mass. Mass of hydrogen is 6 and molar mass is 4. So that gives 1.5 moles of water from mass of hydrogen and molar mass of hydrogen. Okay. For 32 gram of oxygen, the moles of water produced is, for 32 gram of oxygen, the moles of water produced is, moles of water is equal to mass of oxygen divided by molar mass of oxygen. So 32 divided by 32, that is 1 mole. Which is the lesser moles? 1 mole is a lesser mole. And which is the larger moles? 1.5 is a larger mole. So therefore, which is the limiting reagent? Who is the limiting reagent? Oxygen is a limiting reagent and hydrogen is a excess reagent. Okay. since 32 grams of oxygen produces smaller moles of water. Since 32 grams of oxygen produces smaller moles of water and 6 grams of hydrogen produces larger moles of water, hence O2 is limiting reagent and hydrogen is excess reagent. Now, the mass of excess reagent, that is excess reagent means hydrogen, reacted 6 ग्राम में से कितना ग्राम रिएक्ट हो रहा है वो देखेंगे. Now the mass of excess reagent reacted, so that is equal to formula is, पहले फॉर्मूला इस्तेमाल किया था वही फॉर्मूला इस्तेमाल करना है. Mass of limiting reagent divided by molar mass of limiting reagent into molar mass of hydrogen. Mass of limiting reagent divided by molar mass of limiting reagent into molar mass of hydrogen. So mass is 32, molar mass is 32 into molar mass of hydrogen is 4. So 32 will get cancelled. So therefore mass of hydrogen reacted is 4 gram out of 6. 6 में से कितना रिएक्ट हो जाएगा 4. ओके. एंड मास ऑफ एक्सेस रिएजेंट अनरिएक्टेड इज 6 दिया था, 6 में से 4 चला गया. सो देयरफॉर मास ऑफ एक्सेस रिएजेंट हाइड्रोजन अनरिएक्टेड 6 minus 4 that gives 2 gram of hydrogen remains unreacted. Okay. Now the mass of water formed. Mass of water formed. Mass of water formed, it is equal to mass of limiting reagent divided by molar mass of limiting reagent. Mass of limiting reagent divided by molar mass of limiting reagent into molar mass of water. Mass of limiting reagent divided by molar mass of limiting reagent into molar mass of water. So 32 divided by 32 into molar mass of water is 36. So 32 will get cancelled and therefore mass of water form is 36 gram. Mass of water form is 36 gram. Okay. So this is the simple example. Now one example for you, that is 10 gram of nitrogen reacts with 5 gram of hydrogen to form ammonia NH3. Which is the limiting reagent? Find the mass of ammonia formed and find the excess reagent left. Okay. ये प्रॉब्लम आपको करना है. सेम मेथड, मैंने जो मेथड बताई है उस मेथड से ही सॉल्व करो. टेक्स्ट बुक में देखने की कोशिश करेंगे तो आपको कुछ भी समझ में नहीं आएगा. देखो टेक्स्ट बुक में आंसर जो पहला प्रॉब्लम दिया है वो टेक्स्ट बुक का है, उसके आंसर देखो सभी वही आंसर आ रहे हैं, कोई अलग आंसर नहीं है. ओके, दिस इज द टुडेज पार्ट. थैंक यू.